Okay, so in this lesson, we're going to talk about evaluating rational expressions and then simplifying rational expressions part 3. In the simplifying rational expressions part 3, it's just going to be the same type of expressions we did in the previous two lessons. So just be a mixture. Now, evaluating rational expressions, this one, you've done it before in previous lessons. For example, one of the examples you had before was something like this. If, let me write this example 1, if f of x equals negative 2x squared minus 3x, let's say. So we have this quadratic function, and you're asked to find, let's say, f of negative 3. All right, so remember what that means is that you want to find this function value. You want to find this function value when x is negative 3. So you go to your function f, and wherever you see the variable x, right here and right here, you're going to substitute negative 3. So we're going to get f of negative 3 is going to equal negative 2 times. All right, so in place of this x, I'm going to substitute negative 3, and I'm squaring this negative 3. I'm squaring x, and I'm going to subtract 3 times x. Remember, x is negative 3. And so you evaluate the right-hand side using order of operations. So I'm going to do the exponent first here. So it'll be negative 2 times negative 3 squared is negative 3 times negative 3, which is 9. And I'm just going to rewrite this part over. And then I have multiplication, multiplication, and subtraction. So I'm going to do this multiplication first using the order of operations. Remember, please excuse my dear Aunt Sally. So I do multiplication from left to right. Multiplication, division from left to right, although I don't see any division here. So negative 2 times 9 is negative 18 minus 3 times negative 9. So then we do this multiplication. Now remember, subtraction is the same thing as adding the opposite. So I'm going to go ahead and say negative 3 times negative 3. Because remember, from a previous course, you learned that when you have a subtraction problem, you change it to addition. So you add the opposite. The opposite of 3 is a negative 3. And so that's where that comes from. So negative 3 times negative 3 is 9. Negative 18 plus 9 is negative 9. So therefore, f of negative 3 equals negative 9. Okay? So if you were to graph this function, what you found was that when the x value is negative 3, my y value is negative 9. That's what you found. So now, in this particular lesson, though, we're going to be looking at rational expressions. Remember, this is a polynomial expression. This is polynomial. This is a polynomial expression. It's quadratic, though. Polynomial expression. What we're going to look at now are rational expressions. So we're going to do the same thing, but with rational expressions. So it's not that difficult. It's fairly easy. So let's look at this example. So let's suppose that f of x equals this rational expression, x minus 2 divided by negative 5 plus x. And let's say you want to find let's say you want to find f of negative 4, let's say. All right, so f of negative 4. So again, we do it just like we did this polynomial expression. So polynomial function. So this polynomial function is made up of this. So this function is made up of this polynomial expression. This function here is made up of this rational expression. So we want to find this function value. So the function value when x is negative 4. So wherever we see the variable x, I'm going to plug in negative 4. So I get negative 4, that's x, minus 2, subtract 2, divided by negative 5, plus a negative 4. And so simplifying the numerator, negative 4 and a negative 2 is a negative 6. The denominator, negative 5 and a negative 4 is a negative 9. Don't leave the answer like this. We expect you to know, first of all, that a negative divided by negative is a positive, and when you reduce, that is 2/3. All right, so f of negative 4 is going to equal 2/3. Okay, B, suppose we had f of 4, let's say. F of 4. So f of 4, again, same idea. where we see the variable x, you're going to find this function value. So where we see the variable x, you're going to plug in 4. So I get 4 subtract 2 divided by negative 5 plus 4. And so 4 subtract 2 is 2. Negative 5 plus 4 is a negative 1. Again, we expect you to know that 2 divided by negative 1 is a negative 2. So f of 4 is a negative 2. So again, what we found was that when you graphed this next semester in college algebra, what you found was that when the x value is 4, my y value is negative 2. All right, let's suppose we had this one more. Suppose we had f of 5. So f of 5 would be 5 minus 2 divided by negative 5 plus 5. And so 5 subtract 2, 5 subtract 2 is 3. Negative 5 plus 5 is 0. All right, now remember, you cannot divide by 0. That's one of the things we talked about at the beginning of this lesson a few lessons ago, that when you found your restrictions, when you talked about finding the domain, what are the restrictions. So when x is 5, this function is undefined. So we say it's undefined. All right, so remember, dividing by 0, you can't divide by 0, so we say it's undefined. So you'll say f of 5 is equal to, and you'll say is really, in the blank, you'll say undefined. All right. Now, let's suppose we had, let's say we had this, though. Let's say we had f of 2. So f of 2, so you want to find this function value when x is 2. Remember, I'm using the phrase function value. So I want to find the function value when x is 2. So what is that y value? So in other words, what is the y value? What is y value when x equals 2? That's what you're asked when you want to find the function value. So f of 2, again, wherever I see the variable x, I plug in 2. So I get 2 subtract 2 divided by negative 5 plus 2. 2 subtract 2 is 0. Negative 5 plus 2 is negative 3. Now remember, there's a difference between these two. 3 divided by 0 versus 0 divided by negative 3. I can have 0 in the numerator. I just can't have 0 in the denominator. You can never divide by 0. So if you use your calculator, you'll see that 3 divided by 0, you'll get maybe the word error in your on your calculator display. All right. But when you do 0 divided by negative 3, you actually get 0. So that is a value. 0 is a value. So what we found was that f of 2 is equal to 0. Now again, what that means is that if you were to graph this function next semester, what you found was that when the x value is 2, my y value is 0. That's what you found. So when the x value, when x equals 2, y equals 0. That's what you found. Okay? All right, so that was the quick review of what you did before in this course, and kind of the same idea, but this time dealing with rational functions instead. All right, so remember, this is function notation, so this is a rational function. And remember, rational function is made up of a rational expression. So here's your rational expression. Together, this is a rational function. Over here, here's your polynomial expression. Together, this is a polynomial function. Okay. Now, let's go back and kind of review real quick simplifying rational expressions. So let's do this example. So simplify. Number 1. All right, let's suppose we had 6x minus 4, 24 rather, 6x minus 24 divided by x squared minus 16. All right, so remember, the first thing you need to do always is look for a GCF in your numerator and your denominator, in those polynomials. Now, altogether, this is a rational expression. Remember, this altogether is called a rational expression. But remember, a rational expression is made up of polynomials. So the numerator is a polynomial, the denominator is a polynomial. Remember, polynomials, one or more monomials. So these are binomials, but it could be a trinomial, it could be a polynomial in 4 or more terms, it could be one term, it could be a monomial. But together, this is a rational expression. So to simplify a rational expression, you first of all remember this right here, you first of all need to completely factor the numerator and the denominator of the rational expression. So you're going to factor, learning what you did in previous lessons. And then you're going to divide out your common factors in both numerator and denominator. All right, so in my numerator, the GCF is 6. I can take out a 6. Always take out the GCF. You must always take out the GCF, factor out the GCF. So I get x minus 4. The denominator is a difference of two squares. So that's going to be x minus 4 times x plus 4. All right, so I factored everything. Now, you need to recognize your factors. You have to know what are your factors. Well, my factors are 6, x minus 4, x minus 4, x plus 4. Those are your factors. And then when you divide out your factors, you want to make sure that whatever you're dividing out, there's a factor in common both in the numerator and the denominator. It's kind of like when you had 4 divided by 8 in a previous course. So these two factors I can reduce because the numerator and the denominator are both divisible, and let's use the greatest one. The greatest common factor is 4. So let's use the greatest one. I'm talking about this one now. So you'd say 4 divided by 4 is 1. 4 divided to 8 is 2. So you get 1/2. Same idea here. So 6 occurs as a factor here, but there's no factor down there that's a number. That's a monomial, or just a number, let's say. So here you have an x minus 4, you have an x plus 4. You don't see a 12, you don't see a 3, you don't see an 8, you don't see anything like that. Okay? Now the next factor is x minus 4, so you got to ask yourself, do you have an x minus 4 down here? Yes, you do. So I can divide these, just like that. X minus 4 divided by x minus 4 is 1, so you put 1s in their places. And the only thing left over is 6 divided by x plus 4, without the parentheses. And that's your answer. So you simplified this rational expression, you get this. All right. Now, the ability to simplify rational expression can be important next semester because you're going to be graphing these things. So you need to know all about domains that you learned in the previous lesson. You need to know how to simplify them and so forth. All right, number 2. Let's suppose number 2 you had, let's say, 2m squared plus 11m minus 21 divided by 4m squared minus 9. All right, so the numerator, the GCF here in the numerator is 1, so I'm going to go directly to two binomials. And I'm going to deal with the denominator later, but that is the difference of two squares, the denominator. But let's just look at the numerator for right now. Or actually, let's also factor the denominator because it may help some of you to factor the numerator. Now, almost all of you should know how to factor this difference of two squares. It's going to be 2m minus 3 times 2m plus 3. And remember, the idea is that chances are, it's not always true, but chances are something's going to divide out. So either 2m minus 3's will divide out with something up here, or 2m plus 3 will divide out with something up here. So when you factor this, look at these as you do your factoring. All right, so you see this 2m squared? All right, so one's going to be 2m, and the other's going to be m, because using FOIL, 2m times m is 2m squared. All right, let's look at 21. So you have 21 times 3. Now, really, this is negative 21, but let's look at the absolute value for right now. 21 times 3, 21 times 1, 7 times 3. So you see this 3? So you're going to use the 7 and 3 instead. So, now remember what I said. You're going to be looking for things that's reduced. So if you put the 7 here, you know that's not going to work and put the 3 here, because if you put the 7, there's no 2m minus or plus 7 down here. And over here, if you put the 3 here, there's no m plus 3 or m minus 3 down here. So you know you're probably going to need the 3 here and the 7 here. Okay? And you see the 2m and a 3, so there's a 2m3 or a 2m3 here. So it's either negative, this is negative, or it's positive. But remember how you did this. You looked at the outer. So the outer is 14x. The inner is 3x. And remember the last sign is negative, so that means one of these is positive, one of these is negative. So when you see the 14 and the 3, you're going to subtract those. 14 subtract 3 is 11. That's what you wanted. But you remember, you want the larger of those, 14, to be positive. So in order to get a positive 14m, this one right here has to be positive, and this one right here has to be negative. Okay? All right, and then you reduce your common factors. So notice you have 4 factors altogether. 2m minus 3, m plus 7. Remember, factors separated by product. So 2m minus 3 times m plus 7. So 2m minus 3 is a factor, m plus 7 is a factor, 2m minus 3 is a factor, 2m plus 3 is a factor. Remember, you want to divide out your common factors. So right away, I see that these two right here are in common. So when I divide them, I get ones in their places. Just like if you had, let's say, 7 divided by 7. So 7 divided by 7, you know, is 1. But you also think of it this way. You also learned about it this way. 7 and 7, they have 7 in common. So 7 divided by 7 is 1. 7 divided by 7 is 1. And so that's why the same idea here is the same idea here. 2m minus 3 divided into 2m minus 3 is 1. 2m minus 3 divided into 2m minus 3 is 1. And that's all you can do in terms of dividing out your common factors or reducing. So you're left with 1 times m plus 7 is m plus 7. 1 times 2m plus 3 is 2m plus 3. So there's your answer. All right. Number 3. Let's suppose you had, let's see, let's do this one. Let's suppose you had x cubed minus 64 divided by x squared minus 16. So x cubed minus 64 divided by x squared minus 16. Okay, so the GCF up here is 1. The GCF in the denominator is 1 also. But if you look at the numerator, that's the difference of 2 cubes. And the denominator is the difference of 2 squares. So let's do the denominator first. The denominator is easy. So my denominator is going to be x minus 4 times x plus 4. That's my denominator. Now the numerator, we're going to probably have to do some work. But the numerator, remember, is the difference of 2 cubes. And I know it's the difference of 2 cubes because one of the ways that you learned to check this in a previous lesson is to rewrite it like this and then see if you can complete those parentheses, fill in those parentheses. So this is an x because x times itself 3 times is x cubed, and this is a 4 because 4 times itself 3 times is 64. 4 times 4 times 4. So remember, this is your f and this is your L, and so you factor the difference of 2 cubes as f minus L, so it's a binomial times your trinomial, times f squared plus fl plus L squared. All right, and so then you get f minus L, so that's x minus 4, times, and then f squared, remember f squared, remember, means f times f, so if f is x times x is x squared, so that goes here, plus f times L, see FL, f times L, f is x, L is 4, so that means x times 4, which is 4x. So that goes here, plus L squared means L times L, L is 4, 4 times 4 is 16. All right, so x cubed minus 64 is this product of factors right here, x minus 4, and the x squared plus 4x plus 16. So that goes up here, x minus 4 times x squared plus 4x plus 16. And then you reduce your common factors, so these will divide out, the x minus 4s, and your answer is just x squared plus 4x plus 16 divided by x plus 4. Okay. Number 4. All right, number 4, let's suppose we had this. We had 5x, actually let's do this one. Let's do 2m minus 10 divided by 25 minus m squared. All right, suppose we have that. All right, so in my numerator, I see a GCF of 2. So I get 2 times m minus 5. And always check yourself, use the distributive property. 2 times m is 2m, 2 times negative 5 is a negative 10. In the denominator, that's the difference of 2 squares. So I get 5 minus m times 5 plus m. All right, make sure it's in that order. Don't say m minus 5 times m plus 5 because it's not correct. It is not m minus 5, it's 5 minus m. So it's important when you do this, when you keep it in that order. So that's the difference of 2 squares. So that's 5 and that's m. So there's your, well, okay, I'll do f and l. So remember, the difference of 2 squares is f minus l times f plus l. All right, so 5 is listed first. So it's important that you don't say m minus 5. It's 5 minus m. All right, now, just think about what we did in the previous lesson. Here's a factor of 2. There's no factors down here in which I can reduce to 2 with. Here's an m minus 5. I don't see an m minus 5 exactly as m minus 5, but I do know that m minus 5 and 5 minus m are opposites. Remember the word opposites. So the opposite of m is negative m, and the opposite of negative 5 is positive 5. So they're opposites. So remember when in a previous lesson when we talked about opposites, so let's say 10 divided by negative 10. We talked about opposites, and I reduced, let's say, I said 10 divided by 10 is 1, 10 divided by negative 10 is negative 1. And so I got 1 divided by negative 1, which is negative 1. So remember, when you look at the quotient of two factors that are opposites of each other, you get a negative 1. Okay? Now, it did not matter whether, see how these are opposites? It did not matter whether the negative 10 was in the numerator or denominator. It did not matter. You would still, when you divide both by 10, this is negative 1, this is positive 1, negative 1 divided by 1 is still a negative 1. So it did not matter. So when I do this, using what we just talked about, when I do this and to divide opposites, remember these are opposites, I'm going to make this the negative 1 and this a positive 1. Okay? It's usually, if all you have left in the numerator is just a monomial, it's usually best to make the numerator the negative 1, the factor negative 1 now, and the denominator the factor 1. And so if you look at what you have, 2 times negative 1 is a negative 2, divided by, and then 1 times 5 plus m is 5 plus m. So that's your answer. Now, there are other ways you can write this. Okay, so going back to leaving it like this for right now, you need to remember that if someone wanted to say negative 2 divided by m plus 5, that's correct as well, because 5 plus m is the same as m plus 5. Remember, addition is commutative. The way in which you add two things, the order in which you add two things does not matter. Now let's go back over here where we had 2 times m minus 5 over 5 minus m times 5 plus m. Let's suppose that someone instead wanted to say this is 1 and this would be my factor negative 1. It does not matter. You would get 2 times 1 is 2 over negative 1 times 5 plus m. Okay, negative 1 times 5 plus m. But I do need, right here, I do need for you to understand that if you distribute, you're going to get this. Negative 1 times 5 is a negative 5. Negative 1 times m is a negative m. That's still correct also. All of these mean the same thing. It's just that here your numerators had the negative factor. Here your denominators had the negative 1 in it. All right, now the other way to have done that, regardless of whether you use this one, negative 1 over 1, or whether you used 1 over negative 1, is just to pull the negative out in front. So in other words, you could have said negative, this fraction, 2 over m plus 5, with a negative out here. So either one of those are correct. So all those are correct answers. They mean the same thing. Now, see how I had negative 5 minus m? If you wanted to, you could have said negative m minus 5. It does not matter. It does not matter. Okay? All right, so that was number 4. Let's look at this one. Suppose we had, let's say we had y squared plus 2y minus 35 divided by y squared minus 5y minus 3y plus 15. Let's suppose we had that. All right. So the numerator, the GCF is 1. The denominator, GCF is 1 as well. But in the denominator, you see you have 4 terms. So you could do this by grouping. You could do this by grouping, group the first two, group the last two. But you could also, if you look at this, I can combine these 2 terms right here. And so you could write this as a trinomial and then do the 2 binomials. Okay, it doesn't matter. I'll do it both ways, but it does not matter. Let's just keep it as it is for right now. But the numerator, when I factor this as 2 binomials, I'm going to get y. And I need a negative 35 here, and I need the sum to be 2y. So the only thing that would work would be a plus 7 and a negative 5. And always check yourself. Y times y is y squared. A positive 7 times a negative 5 is a negative 35. That's your last. And we're using the FOIL. The outer is a negative 5y. The inner is a positive 7y. When I add them up, I get a positive 2y. In my denominator, again, I'm going to go ahead and leave it as it is. But in my denominator, if I group the first 2 and group the last 2, in the first group, the GCF here is y. So I get y times y minus 5. In the second group, remember, you got to factor out that negative sign here. So in the second group, I'm going to factor out a negative 3, and I'm left with negative 3 times y is a negative 3y. A negative 3 times a negative, remember, negative times a negative is a positive, so a negative 3 times a negative 5 is a positive 15. And notice these 2 groups right here, they have y minus 5 in common. So you're going to factor out the y minus 5, and you're left with, now when you factor out the y minus 5 from this group, you're left with y. When you factor out the y minus 5 from this group, you're left with negative 3. And that's going to go here. So y minus 5 times y minus 3. Okay? So I factor the numerator and I factor the denominator. And then I just reduce my common factors. So the only factors I have in common are these 2. So that's 1, that's 1. And you're left with y plus 7 divided by y minus 3. All right. Now, the other way you could have done it, since these terms I can combine, you could have done that. It did not matter. So if you do that, you're going to get, let's see, that's going to be a minus 8y, a negative 5y, and a negative 3y is a negative 8y plus 15. The GCF in both of those are still 1s, so I'm going to go directly to 2 binomials in both cases. All right, the numerator again is still y plus 7 times y minus 5. That's no big deal. Now the denominator this time looks different than what it did here, although it's the same expression. Those are equivalent. They just look different. Y times y is y squared. The last, what times what, is a positive 15. Let's try 5 and 3. So 5 and 3. The last sign's positive. Remember, that means that these signs in here have to be the same. Either they're both positives or they're both negatives. Is that middle sign. So they both have to be subtraction symbols. All right, and so that's exactly what you had here. All right, so then you just divide your common factors. Y minus 5 divided into y minus 5 is 1. Y minus 5 divided into y minus 5 is 1. And you're left with y plus 7 times 1 is y plus 7. 1 times y minus 3 is y minus 3. So that's what you get. All right, let's look at number 6. Let's do one more. Number 6, I want to do one. Let's see. Let's actually do this one. So 49 minus x squared divided by 2x squared minus 13x minus 7. So 2x squared minus 13x minus 7. And so I'm going to get, so the numerator GCF is 1, the denominator GCF is 1, but the numerator is a difference of 2 squares. And remember, always keep in that order. So don't say, so the correct answer would be 7 minus x times 7 plus x. Don't say x minus 7. That's not true. That's 49 minus x squared. It is not x squared minus 49. Okay? it's 49 minus x squared. So you got to say 7 times 7 is 49. Always check that. 7 times 7, first times first is 49. A negative x times a positive x is a negative x squared. Okay? The denominator, two binomials, the only possibility for 2x squared is 2x and x. The last sign's a negative 7. So I know that one's going to be positive, one's going to be negative. I also know that the absolute value of negative 7 is 7. So the only possibilities for 7, for two numbers whose product is 7, two whole numbers, I should say, whose product is 7 times 1. So let's go ahead and let's think about where the 7 needs to be. The 7 should be here, and the 1 should be here, because the only way you can get a negative 13 is if this is 14. See, 2x times 7 is 14, the outer. The inner is 1x. Remember, the last sign's negative, so that means these are different signs. So when you look at the 14x and the 1x, you have to subtract those, not add those, because they're different signs. So 14 subtract 1 is 13, so that's what you needed. But I need the larger of these to be this middle sign. So 14x needs to be negative. And that's the only way that can happen is if it's x minus 7, and therefore this has to be a plus. All right, and now let's reduce. Let's divide out common factors. If you look at this, there's no factor in the numerator that looks exactly like a factor in the denominator, but these two right here are opposites. See, the opposite of 7, negative 7, the opposite of negative x is x. So remember how we did this, and it didn't matter whether you put the 1 here, negative 1 here, or negative 1 here, 1 here. It did not matter. I'm just going to go ahead and put it in the numerator. So negative 1 and 1. So remember, when you divide opposites, one's going to be a negative 1, a factor of negative 1. The other one's going to be a factor of 1. Okay, so I can write my answer like this if I want to. I can say negative 1 times 7 plus x divided by 2 plus x times 1. I'm sorry, 2x plus 1 times 1 is 2x plus 1. So there's one of the answers. I could also say negative 1 times, instead of saying 7 plus x, I can say x plus 7 divided by 2x plus 1. So that's correct also. I could also have done this. I could also have done, I could have distributed the negative 1. So if I distribute the negative 1, I'm going to get negative x minus 7 divided by 2x plus 1. I could have done that as well using distributive property. All right, so remember this right here was a distributive property. I could have also right here, see that negative 1? I could have also have done this. Let me see if I can find a previous example before I go on. All right, so let's look at this one. See this one right here, where we had negative 2 divided by m plus 5, and then all of a sudden, see where this was negative 2? I could also rewrite it as I'm going to bring it all the way down here, as this. So put the negative out in front of this fraction, because that means this right here means the same thing as negative 2 in the numerator divided by m plus 5. So right here, I could, instead of writing as negative 1 times x plus 7, I could have said, well, that's going to be the opposite of this fraction, x plus 7 divided by 2x plus 1. So where the negative's out in front. So this right here means the same thing as this. Okay. So those are all possible answers. I could have also, instead of having negative 1 up here, I could have had negative 1 out there, and you'd have a whole new set of answers. But they're all the same thing. Okay? So, in other words, let me go ahead and do that here just to show you. But it's important. It is important that you see that all these mean the same thing. So, in other words, going back, I'm just going to go ahead and rewrite all this over. So, if I rewrite all this, I get 7 plus x divided by 2x plus 1 times x minus 7. All right. So knowing that these are opposites, so I could say 1 instead here, a factor of 1, and this would be a factor of negative 1. And so your answer would be something like this. You could say, well, 1 times 7 plus x is x plus 7, or 7 plus x, divided by negative 1 times this. Something like that. 2x 2x plus, 2x plus 1. All right, or I could have distributed the negative 1. It does not matter. So I would have x plus 7 divided by negative 2x minus 1. Or I could have, see this right here, just like I did right here, just like I pulled the negative 1 out in front, pull that negative out in front, I could have done the same thing here. Although it's just in the denominator, pull it out in front. So that would have been a negative out here, so the opposite of this fraction, x plus 7 divided by 2x plus 1. All right, so all of these, and all of these is the same answer, is equivalent, they're equivalent. So either of those answers would be okay when simplifying this. Okay? All right, so this was a long lesson, but hopefully the examples in this lesson will help you for My Math Lab and the worksheets.